colleagues. So I'll be presenting a lesson on project economics. It's part of the engineering orientation course, which doesn't exist yet, but is proposed to replace Introduction to Engineering. Which of the following is the most valuable? Just take a moment to consider. Okay. I didn't ask which one of these you prefer to have, Okay, who says A? B? C? Alright, so C? D?
Valuable now.
Anybody says E?
Okay.
Well, what you were probably trying to do is that you were trying to figure out the value of each of these different options today. That's what you were trying to do. Because you would have realized that cash flows in different years would be worth a different amount. Like $10,000 2 years ago could have purchased more than what $10,000 could purchase today. So this is something everyone could identify with. Companies need to do this every single day because the projects they would put money in today would have to give them a return sometime in the future. So how do you make that decision today as to what projects you would get involved in? Now, if companies had unlimited money, if governments had unlimited money, there would be no need to be doing this type of analysis on a continuing basis. For projects to continue in countries, for companies to survive, they always have to be taking on projects that will increase their value. So therefore, they have to make decisions today to take on projects that will increase their value in the future. Right? Maybe UE has unlimited money, but organizations and governments, they always have to be doing a juggling act. So how could we go about making a more informed decision? So what you really needed to be doing is to be doing something called discounting. Now, forget about everything you know about discounting. That is not the definition that we are using. This is not the model. So what discounting is converting a future sum to a present equivalent, or a present sum to a future equivalent. So we have a cash flow sometime in the future. We want to know what it is worth today. And to do this discounting, you need to use this formula here. This is the cash flow in year N divided by 1 plus the discount rate to the power of the year. That is the compound interest equation. That is how you find the present value of a cash flow. So if it is, we have to look back at this example, the pretest. I calculated the value of those cash sums today. The only one you know for sure is the $3,000 because $3,000 the present value of $3,000 is $3,000. Right? All the others, I had to apply the formula to find out what it's worth today. I use a discount rate of 15%. This discount rate is determined in one of two different ways. It could be the company's cost of capital, or if you have an investor, the investor's expected return. For example, if it is you wanted to invest in a little venture, make some money, you know. Obviously, you're not going to borrow that money at an interest rate more than what you could get back on your little venture. So you have to consider your cost of capital. You can use that cost of capital, how much you bank want, as your discount rate. Right. So, in order, what companies would do, and Trinidad and Tobago has one of the biggest projects in the world, for example, in Atlantic LNG, was over $1 billion US. How did these people work out how they were going to get that money back? Right? But companies have to do this every day. Even if they have to replace a forklift, they have to do this every day. Right? You can find the net present value, which is the difference of all the cash flows over the years of the project minus the initial outlay, the money they put out at the very beginning. So if it is they put out $1 billion US plus for Atlantic LNG, they will have to investigate that over a period of time. And every positive NPV project is a good project. So how does this work? This is one example. So a company is buying a new machine and they have a 10% discount rate, and you have to evaluate whether this project is a good one using the net present value method. So they put out $400,000 in year 0, which is present. So it's negative because that's money going out. And so minus $400,000, present value simply minus $400,000. Then at the end of year one, they get $100,000. We have to find the present value of that. And our discount rate is 10%, so 100,000 over 1.1, and that is $90,000. And in year 2, $350,000, it equates to this. This is now raised to the power 2. And unfortunately, this project is a bad project because it's a negative NPV project. So, what if the discount rate was 5%? Suppose we got an investor who only wanted 5%. You have your calculators? So the only thing you really have to change is the discount rate. Instead of 0.1, 10% is now 0.05. Or you can use Excel.
You could use your brain.
Would we now accept this project, or would we reject it? Right? It's now positive NPV.
Yeah.
So therefore it is a good project and we would accept it.
You see why none of us are the entrepreneurs in the country who can't do the math in our head?
Well, when you have unlimited money, you don't need to do this. You can just do all the projects. Okay, so for the post-test, this is a fill-in-the-blanks question. A project with a net present value of $5 is A. You have to choose from one of those below. This whole thing is built on Schoology, by the way, if you want to go back through it. And the discount rate for a project is aligned to the cost of capital of the,
Company.
or the expected returns of the,
Investors.
right, and the first one was a project with a net present value of $5 is a good project. Every positive NPV project is a good project. Right? And this is the summary. Right? So in this case, the example you was given, the cash flows, at times you need to determine the cash flows. It could kind of get a little complex, but essentially this is one major method that all companies use to evaluate the projects in which they will invest. And that's it.